The system used in our G-series casting machines is a vacuum overpressure under inert atmosphere. The casting pieces have a very smooth surface, a very dense molecular structure, and no defects such as improper filling, porosity, and shrinkage. In our system, both the flask and crucible are located in a common chamber, which is first fully evacuated by vacuum before melting, followed by helium gas supplied to create an inert atmosphere. Helium gas presents excellent gas fluidity, which provides a cleaning effect of the molten metal and mold and guarantees a smooth filling of metal, even with the most intricate patterns. The casting temperature is attained, and low-frequency pulses are given to vibrate and mix the molten metal by keeping it homogeneous. At this stage, the flask is pushed against a long-lasting special metal sealing blade system, or SBS, which, like a knife, cuts the investment by sealing the vacuum underneath the flask. This long-lasting system avoids the use of silicon gaskets or a flask with flange, with an important reduction in casting costs. The metal, once completely poured into the flask, is pressurized by argon up to 4 bars. This pressure, being applied to the molten metal, forces it into the mold while the vacuum pulls it. This results in a very smooth surface due to the effect of the vacuum and a dense, well-compacted casting due to the overpressure, which benefits both thick and thin sections. In most of our competitors' machines, the metal cannot be effectively pressurized up to 4 bars, since the machine's structure does not allow for this, and under this pressure the cover will blow out. During normal use at 1, maximum 2 bars, the applied gas pressure above the crucible can only act on the metal once the mold is occupied by jetting through the crucible feed hole to the underside. The effect of this pressure is drastically reduced by drag of the crucible holder, etc. In fact, application of gas overpressure by this method shows no significant advantage over a simple gravity vacuum system. A further disadvantage of these machines is that there is usually a gap of 4 to 5 centimeters between the crucible feed hole and the flask entry, which frequently leads to splashing and gas absorption problems. In the separate chamber machines, the syringe effect is guaranteed by special gaskets and cements underneath the crucible to keep it sealed. After the vacuum is applied, the flask is pushed against a silicone gasket and inert gas is supplied. When metal is molten, it's poured into the flask. At the same time, a gas pressure is applied to the crucible chamber at 1 bar maximum. When the crucible gasket and sealing are proper, the gas pressure will push out the metal from the crucible by increasing its pouring speed, while the vacuum pulls it. But when the crucible gasket and sealing are worn, after a few castings, the gas pressure goes through the crucible ceramic holder and it's absorbed by the metal. This phenomenon, together with the metal injection speed, creates gaseous formations, which cause improper filling, damage to the investment and rough surfaces, as in the old centrifugal systems abandoned a long time ago for the casting of gold and silver.